Okay, so last week we have seen the differences between the structures and classes. And one of the conclusions was that classes are like structures because they group together attributes which describe an entity. Okay, so we started the example with the student, include IOStream. And today I will use the shortcut. I will avoid the standard prefix. So let's use the using namespace standard. Okay. And the only difference from that perspective, let's say from the last week course, is that when we define a class, we use the class keyword instead of the structure keyword. A very important aspect here, and this is a common error, which you will encounter because by mistake you delete this semicolon, is that a class definition should always be followed by this semicolon. Okay, and you see Visual Studio and other IDEs, other environments will add this automatically. So if I want to do here another class, let's say faculty, at this moment when I open the brackets, you see I get the closing bracket and I got the semicolon. Now, if by mistake you lose this one, let me show you. The error, it's quite confusing, and that's why I want to show you this, because the error it's already here. So let's do a build. And the error is faculty followed by int is illegal. And you see it's also giving you a question mark. Did you forget a semicolon? Now, this is a new message. Generally, you will see this one, expected a semicolon. But if you double click on this, if you double click on the error in order to see which is the line which generated this, or you also check the line number here, you see the line number is actually 12. So you may think it's a problem with this part here, which is the definition of main, which is correct. And you see, it's saying that here we are expecting a semicolon. So that's why sometimes it's confusing, because it's showing you the instruction which follows the closing bracket of the class. Okay, so watch out for this kind of errors. It's easy to do them when you, I don't know, by mistake you delete the semicolon, or your environment is not generating the closing bracket and the semicolon. Okay, so if you see expected the semicolon before a function or something in a strange location for which you don't expect a semicolon on this line, just check the lines above that. Maybe that's where your class definition ends. Okay, so all class definitions should end with a semicolon after the closing bracket. Okay. Now, regarding classes and structures. So at this point from last week, we know that the class is a collection of attributes. And in that way, we can actually manage the data of an entity instead of having multiple variables, multiple arrays. For example, for student, let's go for a name, and I will go for a static array of 100 characters. We had also what? We had the boolean, bool, okay, has a scholarship, okay. And also here we can go for age, okay. And this will be a student. Now, for a faculty, we can actually go for another definition. So let's say, and in this way, I can show you different stuff here. For example, I can go for a dynamic name, because the name of the faculty can vary. Let's say we don't know for sure if it will be 100 characters or more. So here I will say, again, name, which is the name of the faculty. And what else do we need for faculty? Maybe we need the address of the faculty. So for that regard, we will start using, like I said, C++ tools. And one valuable tool which we can use, and I will mix them in all our examples, is to actually use something which will wrap up this approach, which is a dynamic array of chars, or this approach, which is a static array of chars. And you see, in human activities, working with array of chars or strings, it's common because we provide descriptions, we have names, we have a lot of stuff, and many values are represented by either numbers and also by arrays of chars or strings. So from this perspective, they introduce in C++ something which is much more, let's say, easy, much more efficient, or let's say productive, in terms of how much code do you need to write in order to do simple stuff like copying an array of characters, printing an array of characters, I don't know, subtracting an array out of that, and so on. Generally, to process strings, because strings are common, they have introduced a new data type. But this data type, it's an object. Okay, so we are using a class which is already predefined in the C++ standard libraries. And this class is called string, and we will start using it. So we will use it along the classic implementation of char arrays, which we inherit from C, which is a static array or a dynamic array. So let's write the address. Let's define the address as a string. Now, the string object, but you see, we are using it as a type. The string object is defined, and we need to include that library here in the string library, okay, without .h. Remember, we have used at some point, and we will still use for these types, a library which is inherited from C. So this is a C library, which is called string.h. Remember the difference between libraries which end in .h and libraries which they don't have the .h. So these are C++ libraries. This is a C library. And here in string.h, you have all the functions that you made used before, like string length, string copy, string concat, and all the other functions for processing strings. Okay, so we will use them both, but we are already at an object-oriented course, so why not use something which is very easy to use and very productive, especially for an array of strings. Now, in order to actually learn how to use a string, you need only 1 minute, because actually the string object, the string type, it's something we all wanted since we learned how to code. Why? Because it will behave like a primitive. It will behave like a VB, like an integer, for example. So let me give you some examples just to show you that you can learn how to use string in 1 minute. For example, if I want to define a string, I will say message. Okay, let's say string message. And if I want to initialize it, we all know that initializing a variable should be something simple like variable equals value. So let's say course 05. Okay, so how do we initialize a string? Using equals. Okay, we don't need string copy. We don't need to concatenate. How do we concatenate? For example, if I want to concatenate something to an existing string, I can say message equals hello plus message. So in order to concatenate two string objects, again, I will use the plus operator, which we were using also for numeric types to do an addition. Now, plus here will do a concatenation. Okay, so now the message will be hello course 05. So let's see that. Cout end line message. Okay, so if I will run this build rebuild. Okay, and now if I do start without debugging, then I will see hello course 05. Okay, so it's very easy to initialize strings versus do the same stuff with static arrays of chars or dynamic array of chars. Okay, now what else can we do? For example, if we want to count the size of a message for classic char arrays, we were using string length, strlen. Now this is an object, and we need to get used to that because objects are much more powerful than a primitive data type like a char array, because objects, they have methods. So if I want to see the length of the message, okay, so all the other functions that you remember from string.h, they don't work on the string type. Okay, this is a type particular to C++, then I will say this: the length of the message is, and now we need to get used to ask objects to do stuff for us. For example, message dot, and you see it's behaving like a data structure. Okay, and here you see that it has a lot of methods. Okay, so just activate the IntelliSense and you'll see append, assign, add, back, begin, and so on and so on. So let's see if I see somewhere here length or size. Okay, length, here it is. So this is the method, which in this case will return the length of the message. And if you need to process strings, you don't need to learn by heart all these methods. You just need to be curious and just try to see how you can use them. Okay, substring, find first of. So this is a search method. Append, let's see, do we have a lower? No, we don't have a lower or to upper. Okay, so it has quite some methods you can use in order to process that string. So let's see, build, rebuild. Okay, and now debug start without debugging. And here it is. The length of the message is 15. Again, length as string length, which we know from C, will always return the number of visible characters. Okay, so it will return the numbers of the printable characters without the \0. But the string itself will manage its own \0. So again, we don't need to worry about that. Again, if I want to change the message, I can easily change it. So no one will be upset about that. For example, the end. And now it's changed. Okay, so I can play with that message quite easily. Okay, so starting today, we will also use the string type, which is an object type for attributes which require a text. Like in this case, we have the address of the faculty. Okay. Another thing that we have seen last week is the fact that starting with the first, let's say, difference, that now we are using a class instead of a struct. Classes and object-oriented, it's about control. And the first thing that I showed you is that by default, you have full control over the content of this class. So when you define a class, you are the owner of that class. So in this case, I'm the owner of the student and the faculty class. So I have control to decide how other programmers will use my class. And that control means that by default, if you try to initialize a student here, okay, so let's say student, if I try to access a variable here, for example, if I try to initialize the age of this student or to print it is the same. So let's say student dot, and again, the IntelliSense is not suggesting anything, but sometimes the IntelliSense is not working. So there is always a reasonable doubt to believe that maybe it is broken. So sometimes you just try to write yourself that. So if I try to write student age equals 21, I get here the member, okay, student age, and you see it's showing us where this is defined. So is the age attribute of the student class is inaccessible, which means at this point, no one can access anything from here. Okay, so no one can either read or either change the values there. For example, if I try to write this student age equals student.age, again, I will get the is inaccessible, you see? So no one can access directly the content. And this is a big difference between classes and structures. By default, you can't access the content. How this is done? They introduced these keywords, which are called access specifiers. So by using these keywords, you can decide which parts of your class, which parts of the class body can be accessed by others directly. And by default, a class, when you define it, even if you don't write anything, gets this access specifier. So this is a keyword specific to object-oriented, and you will find this keyword in C#, Java, all object-oriented languages. So by default, even if you don't write this, the compiler is actually adding this line for you. When you hit build, you get that line. So the source code is compiled having this private label here, which means the entire class now it's private, because all these labels, they will affect the source code which follows their location until the end of the class or until you are using a different label. So in this way, you can define private areas in your class or public areas in your class. And we will see that in 3 or 4 weeks, there is a third one, which for now, I can mention it, it's called protected. But for now, protected has almost no meaning to us. It's almost like private, okay? So these are the 3 access specifiers: private, protected, and public. But for the moment, protected has no meaning because it will have in a new context, which is called inheritance, which we will cover in 3 weeks. So by default, the class is private. Remember this. And this is also available in all object-oriented languages, C#, Java, and so on. So how do I change this? For example, if we want to make age something that someone can access, I can add the opposite label, which is called public, which at this point will make everything which follows this line here, line 10, until the end of the class will make public, which means now you see the error has gone. Anyone can access the age of a student either for reading it or either for changing it. Okay, so this means public. And actually, if you define a class public, if you set this public here, now you overwrite the default private, which means now the entire class is public. Now, this class is very similar to a structure because by default, all the structures are public. So if you write this public here, now is kind of saying, hey, I don't want the control. Okay, so now you actually cancel the advantage, one of the advantages of object-oriented programming, which means you have full control on deciding how others can access, can use your class. So generally, we will not do this. Okay, we will not define this public here. Even if we can, we don't do it because this is like learning how to program in object-oriented philosophy. And after that, we still program like in C with data structures. Okay, so we don't do this. Now, this principle, which is actually blocking anyone by default to access anything in your class, this is called encapsulation. And you have a slide with that. So just note this keyword, note this concept down and remember it. I will use it many times. So this is called encapsulation. And it's a very important characteristic of object-oriented programming because encapsulation means take the entity, take the student, take the faculty, put that entity in a box and seal the box or lock the box. And you are the only one who has the keys. Okay, so you are the only person which can allow others to open the box and access something inside that box, which is the content of your object. Okay, so remember, encapsulation means make everything private and after that decide. So let's learn how to code in, let's say, in pure object-oriented philosophy. So even if you write here private or don't, or you don't write, that's a good thing. So by default, you benefit from encapsulation, which means all your attributes are safe. No one can change them directly. So in this case, I will remove the public here and you will see today a good reason when to use public, but generally we will not use it for our attributes. So encapsulation means make your all attributes private. Okay, name, has scholarship, age. Okay, so why do we do this? Remember what we talked last week. When you define a class, you are responsible for the quality of the data which will get here. So this will be an object which will encapsulate all these attributes. And at some point, you will save the data of the student in a database. Or the secretary will ask a report for all the students with all the students which have scholarship, or all the students which have an age below or greater than a given limit. So you see, you are responsible for the quality of the data, which in the end will be used to initialize all these variables, all these attributes. You are responsible. So if something bad will happen, everybody will point to you. Because in the end, if you make the age public and another developer will take a value from the UI, from the console, and by mistake, because they will not validate, because they will say, hey, it's your job to be responsible, no one will validate. In the end, this student will get a negative age, because let's say by mistake, the secretary or the user will input a negative number. And because no one validates, because everyone will expect that you will validate, you see, this is passing responsibility. Everybody will say, no, it's not my job to do that. Okay, he will do it because he's the owner of the class. So that's why it's very important to understand that you need to keep this control. Okay, because in the end, you are responsible for the data which will be stored here. And this is the reason why we make everything private. Now, sometimes maybe this data is sensitive. Maybe it's a password. You don't want to allow, I don't know, your colleague which develops another module to easily access the student passwords. Maybe you store them here in memory. So sometimes sensitive information should be protected. No one will be allowed to see that because it's sensitive, the password, and so on. So there are many, many, many reasons to actually keep the data encapsulated, which means keep them private. Okay. So at this point, no one can insert here a negative age, but in the same time, no one can actually see the age. So at this point, everybody will say to you, hey, your class is great, but it's useless because we can't use it. We can't read values. We can't store values. So in order to pass this, we need to provide a way, but a controlled way by which our colleagues, other developers, or even us later will be able to access this encapsulated data, but by following some rules we decide. So encapsulation means make all your data private. And the opposite of encapsulation is define a public interface. So let's see, what's an interface? You know that from the first courses of IT. So you know that an interface between you and the computer, actually the microprocessor, is given by what? The keyboard, the mouse, the monitor, the screen, right? So an interface is something that connects two things, which normally they are not directly connected. So an interface is like a bridge, right? So that's why this is called the public interface of the class, which means, and remember, this way of talking, all these keywords which I'm saying to you, all these expressions, like this is the public interface of a class, all this vocabulary is the same in C#, Java, and all object-oriented languages. So if you learn this vocabulary, if you learn to speak like this, because we will describe things from object-oriented philosophy and we will use these keywords, and this is the way you should also talk the discourse, using these expressions, these keywords. In that way, you are actually learning the object-oriented philosophy for all those languages, because all these expressions are also valid there. So when you will code in Java, someone will say to you, hey, define a public interface for that class. It will say the same stuff and it will have the same meaning. The only thing which will be different is the syntax. Okay, so what's the public interface of a class? The public interface, it's a set of methods. You see, public interface is not an attribute. Attributes are encapsulated, are protected. A public interface is a set of methods. So here inside the class, we can actually define functions. And this is another big difference between classes and structures. because in this way, we can actually group together functions which are processing an entity like a student with the data which represents the student. So this is actually the big step that object-oriented provided in terms of evolution of programming languages. Before that, you had entities like structures, which could have data, and you had functions in libraries. So they were not connected. They were only connected because a function like print student, which we wrote last week, was receiving a student. So that was the way they were connected, but physically they were separated. Now here they said, hey, let's create a much more powerful entity which will aggregate together attributes and functions. So in a class, we can actually also define functions. And generally, the functions that we define here on the public space of a class are called the public interface. Okay, because in this way, others can interact with the private space. You see, this is, you have the keys to the box, and these functions are different, I don't know, buttons on the box, or different rules by which others can actually interact with the content of the box, which is protected by you. So let's define here a public interface for all this stuff, and you will see what I mean by control. So at this moment, no one can access either for reading and writing age. Now let's allow them only to read the age. So I will define here a method. So generally these methods which provide the read and write access to attributes are normally named using get or set. Generally get is for allowing read access, set is for allowing write access. So the pattern for these methods names looks like this: get. So in this way, everybody knows that you provide read access. And now you say get age. And let's understand another difference between structures. You see, in the procedural way of programming, okay, functional programming, procedural programming, sorry, functional programming, it's a different stuff. It's a different paradigm. In procedural programming, we always pass the arguments to the functions. So right now, you may say, so in order to give access to the age of a student, here I should provide a student, right? So let's say student. And here in get age, what get age should return? Get age, it's a function which should return to others the age of that student. So obviously the get method will return a value which has the same type with the attribute for which you want to provide the read access. So here I will say return student.age. Now, you see, every time I write a function here in the class, I don't have the issue with encapsulation. Why? Because this is my courtyard. Okay, so this is me. This is the class. So all the functions defined in the class, they have free access to everywhere here. And this is normal. Okay, this is like living in a house with your parents. So you all have access to the same resources in that apartment or house. But for strangers, the access to that location is forbidden, right? That's why you close the door. But inside the home, all the family members have access to all the resources, right? So this is the same philosophy here. So all the methods that we define inside the class will have access to everything. So private is something which restricts access to others, like main. You see, main, it's a function which has no relation with the student class, is not from student. So main is like an external entity. And that's why it cannot access age, because it's from outside the class. But functions defined inside the class, they have no issue with private. Actually, private doesn't mean anything to everything you define here. So here, I will define get age by using the procedural way of programming. So if you want to see the age of a student, then you need to ask the student. Okay, so how do we call this method? It's public, which means I can access it from exterior, from main, for example. So how do I access it? So if I try to access it directly, like get age, so let's define another variable, student age equals, and here I would say get age of student. At this point, the compiler will say, hey, identifier is undefined, which means it doesn't know what's get age. Where is this function defined? And we see it here, but we actually realize now that this is not a global function. It's not like I will define a function here. Because if you see, if I define it here outside the class, again, I have the same error, is inaccessible. So get age now, it's an external method. I don't have the compiler error here anymore because get age, it's a global method. The compiler sees the definition here, but now get age is not part of the student. Okay, it's an external class, it's an external method, so it doesn't have access on private. Okay, so I solved an issue, but I'm back to the initial issue. How do I access the age? So it's obvious that get age should be defined inside the class because here I can access age. Now, why the compiler does not see get age? Because as we were accessing attributes using an object or an article, you see, if we wanted to access age or has scholarship or name, we need to use a student entity or a student object, like here. This goes also for all the methods that you define in a class, with the exception of static methods, which we will do in 1 or 2 weeks. But at this moment, if you define a method inside the class, in order to access it, you need to use an entity of that class, and that entity is called an object. So in order to access it, okay, I need here a student. So I will say student.getAge, and you see when I press the dot, the IntelliSense will always suggest you things which are public. You see, I don't see age has scholarship name. I see get age. Okay, so get age student. And at this moment, you may say, okay, so I will define all my attributes private. I will define methods which will allow others just to read the age or those attributes, because at this moment they can't change them. So we are good with that. Now, let me show you something strange in order to understand the next principle of object-oriented. So if you look at this line, is any of you have a strange feeling about it? So do you see here something that you don't like, something like redundancy? So you see, in order to call a method from the class, I need an object. So I need this student here in order to call get age. And after that, I need to pass the same variable here, right? So it's student get age student. So I see this redundancy, which looks strange. And just to make things even more stranger, let's define another student. So student new, let's say, or yeah, let's define student John. Okay. And now let's say this is here I want to get the age of the student, of the initial student. And if I want to get John age, at this moment, it feels that I can actually write this, sorry, or I can write this, student John. So this is quite even stranger, because this is like, in order to get John age, you need to ask the other student, what's John age? So do you know all your colleagues' age or other personal data like birthday? No, we don't know. So a lot of stuff is related to only that object. And if this looks strange, that we have this redundancy, or that it's quite easy if we follow this path to actually say student get age of John, okay, and logically that should not make sense. Like I said, each object will have its own data, and generally you can't ask an object for another object data because everything gets encapsulated in those objects.
Sure.
Yeah.
By this thinking, shouldn't it be student John dot get age student John?
That will be even much more stranger. Something like this, right?
And no, at the beginning, like after the equal.
Here.
Yes,
Yeah.
John.
So yeah, it should be like this. But you see how easy it is to do mistakes? This is what I want to show you. You see how easy it is to say student get age, student John, instead of saying student John get age or student John. And what's the reason for this? So let's find the root of this. Why can we do this kind of mistakes to mess up which student is getting the age for which student? Because of this redundancy. So I think this is too much. Okay, so okay, I understand that in order to get the age to call this method, I need an object here. I understand that. It makes sense. But what I don't understand is why we need to, again, to pass the same student here and here. And you see, we can easily do mistakes because here I will pass another student. And this doesn't make sense in real life or here in software. So because of that, we need to understand that in object-oriented, because you have this rule, which says in order to call a method from the class, you need an object from that class. You see, I can't call get age without a student. So this is the main rule of object-oriented. Everything can be accessed by using an object here. Because we have this rule, they said this, hey, because all the methods are actually called by a student, we will give you a bonus. So all the methods defined in this class, with the exception of static methods, which we will cover in 2 weeks, all the methods will receive by default. So you can't change it. You can't change it. Okay. You either program in object-oriented or you stick with C. Or and in that way you don't go into Java, C#, because all the object-oriented languages do this. So all the methods that you define in a class, they will receive by default. So it's a bonus. It's a free gift. You can just ignore it, but you can't refuse it. Will receive, and this is the catch. Okay, that's why I insisted on pointers. Will receive by default the address of the object which will call that method. So you see, we can't escape pointers. They are everywhere. So when you code object-oriented in any language, all the methods which are not static defined in a class, by default, they need to be called by an object of that class. And by default, they will receive the address, not the value, the address of that object. So here, actually, this method has a default attribute. We don't see it, but it's there. And that attribute, it's called this. Okay, and this is the name for this attribute in all object-oriented languages, Java, C#. So here, instead of saying, hey, I need a student, you get a student. You get the address of the student, which will call get age. So here I will say this, and this is a pointer. Okay, so let's write it here. Receives by default the address, and which are the variables that we are using in order to store an address, pointers. Receives by default the address of the calling object, which means is the object which will call this method, because you can't call it without an object. We tried that and we got an error. So receives by default the address of the calling object. And in this case, the pointer is named this. This is the official name. You see, it's a keyword from C++. It's written with blue because it's a keyword. Now, what's the type of this? So we are in the student class. If I will ask you to define this, how would you define it? Can you give me its type? If this it's a pointer to a student, how do you define it? No one? So how do you define a pointer to something?
It should be student star this.
Exactly. This is this. Yeah, it's perfect. So this is this. So by default, all the methods that you define here, they get this. You don't need to write it because you get that for free. Okay. And if you write it, you'll redefine this, which is not allowed. But you need to see this. So every time you define a method in a class, you get this argument. It's the first one in that list. If you define others, this will be the first one. So remember, this is very important. So because this is a pointer, you know the difference between pointers to articles and pointers to values. If you remember from first year, when we play with values, in order to access something from the class, we are using the dot, right? So here I'm using student age, student.age, student has scholarship, student.name. But if you play with the pointer to a student or a pointer to an article, then they use a different operator, and it's not dot, it's arrow. Okay, so every time I'm using this, I will use the arrow operator because this is a pointer to a student. It's not a student, it's just the address of a student in order to access its attributes or its methods. And you see now the IntelliSense is saying, okay, you can access the age, the has scholarship, or the name attribute of this object. Okay, so right now I will say this age. In Visual Studio, even if you write a dot, because at this moment we are all used to use dots. So this is a common, I will do this mistake from time to time because I will just code and speak and I will not focus on writing. So even if I write dot, you see the IntelliSense is saying, okay, it's like it's saying, hey, you are a Java developer, because in Java there are only dots and C# in the same, there are no arrows. Okay, so even if I choose age, you see it's converting the dot to an arrow. So even if you type with dot, the IntelliSense, the environment will replace the dot with an arrow. But if you still continue to use dot, then you will get the compiler error. You say it's saying expression must have a class type, but it's a pointer, which is saying, hey, you are using dot if this was a student, but this is a pointer to a student, so don't use dot, use arrow. Okay, so this is again syntax specific to pointers. So for this one we are using pointer, but in the first time we will use pointers to objects like this. Fortunately, Visual Studio will replace the dot, so you will still use dot. I will see that also at the exam. You press dot, but in the end you get the arrow. But now sometimes you need to specifically write the arrow because Visual Studio will not help you. So remember, if we are using pointers, then we are using the arrow. If we are using objects, we are using the dot operator. Okay, so at this point, I understand that by default, I will get the student, so I don't need to ask for the student, which is great. And here I can return that student age. So let's go back to main. And you see, now I don't need to pass the same student from here. Okay, and now the code looks much more cleaner because I can't do the previous mistake. Every time I will say student get age, now it's very clear that I want to see the age of the student. If I say student John get age, it's very clear that I want to see age of John, right? So in this way, we are now sure that every time you use an object to call a method from that class, we will get the data, or we will process the data of that object. So we don't need to write the same student here, which is redundant, which is risky because it can generate errors. Okay.
I have a question.
Yeah.
Even though perhaps it has been explained, we've had some problems with internet for a while. Anyway, could you tell me why there is no dot or any other symbol between student and John?
Here?
Yes.
Because this is a variable name.
Ah, so it's an entirely different variable. Okay.
Yeah, it's a different variable from student. So I had the, let's say, imagination blackout moment. So this was the first idea to make a difference between this variable and this variable. So I call this one student John and this one is student.
Okay, thank you.
So I can also call this one student Alice. Okay, now we have Alice and John. Okay, or we can call them Alice and John directly. Okay, so it's just, it was just a choice of naming the variable. So that's just a variable, okay?
Okay, thank you.
Okay, so we have seen what's this. So this is the address. Always remember, it's a pointer. It's an address of this object. And later when you say student John get age, inside this function will be the address of student John. So at this moment, you see, others are actually starting using our class. So initially they were not allowed to see or change the age of a student. And by providing this public interface, now they can actually see it. They can actually read it. So our class student is become useful because we will store data there, and others will be able to check the student age for John or Alice. Okay, so let's print the value. Let's see what's Alice age. So Alice age is student age, or I can call this directly because here you see I'm using the same variable. So right now actually student age is John age. So I can actually call this directly here. I don't need variables. So I will say student Alex get age. So let's see, build, rebuild. Okay, and debug start without debugging. Okay, debug start without debugging. And this is it. So this is Alice age is minus 858. So what's this value? Have we seen it this before?
It's the predefined by the
0x, exactly, is the 0x CCCC. Remember, this is what we get in Visual Studio. If some of you are on Linux right now, you should see here 0 or another compiler. But in Visual Studio, we get that. Okay, so you see by default, again, you get here 0x CCC for all of them. Now, let's finish this public interface. So how do we define a public interface which will allow read access to has scholarship? For example, someone will try to check if John or Alice has a scholarship. So I will say get has scholarship. And you see when scholarship, when we define this for Boolean variables, doesn't sounds too good. Okay, get has scholarship. Okay, and because of that, again, for Boolean variables, remember we generally start their name with is or has, because generally that will mean a true or false. It's either having something or is something. Okay, for this kind of stuff, again, we can actually ditch the get. Okay, because it will sound much more interesting without the get. So we will have the has scholarship function. Okay, and now it's different because this is a function, this is a variable. So generally for Boolean variables, the public interface is not having the get or set, or at least the get. Okay, so because it's the first time we see the public interface, let's write it. But starting next week, if we have a Boolean attribute, we will try to figure it out a better name for this function. Get has scholarship doesn't sound too okay. Again, the return type is the same with the attribute. So again, here I'll say return this has scholarship. Okay. Now for the name. So for the name, again, I'll say get name. Okay. And here you will say this should return the value of the name. So here we should write the type of the name. So again, you will say, hey, the name, it's a static array of 100 characters. So we need to return it. And again, every time you play with arrays of characters, even if they are static or dynamic, don't write this. Okay. Go for char asterisk, okay, because this is the generic way of managing array of strings or array of characters. So always write char asterisk. Remember, we had this discussion last week. Also, when we receive a value, a char array, we will always receive it by a char asterisk, and sometimes a constant pointer to a char. Okay, so here I will say return this name, but this is something we need to get back to. So let's write this comment. It's not okay. And this is a mistake that it's very easy to do. And you'll understand later. If we have time, I will cover that. If not, next week, I will explain you why this is not okay. Let me give you a glimpse. Maybe some of you will realize what's the issue here. So what's the main principle of object-oriented? Encapsulation, which means I will not give you direct access to that. I will control how you access this, the variables. So at this point, I want to give you only read and write, only read access. So get age, get has scholarship, get name. But what do we return here? You return the value or you return the address of the student name. So what do we return here?
The address.
The address. So if I'm giving you an address in memory, can I stop you to read and write at that address? No. If you have the address, you can do whatever you like. So you see, when you have arrays here in your class and you write the public interface, the getters, don't do this mistake because you are actually giving me read and write access. Okay, if I get this pointer, I can do anything at this address. I can change your name and you provide me only a get name method. Okay, so this is the issue. We need here to think differently the get name for arrays, the get methods. Okay, now for the moment, let's see. So I have the get name, I have the get has scholarship, I have get age. Okay, that's cool. So in this way, I have read access from here. So I see Alice age is, let's see, Alice name is, that will be interesting to see it. Student Alice get name. Okay, let's do a build rebuild. Okay, debug start without debugging. And this is Alice name. So this should be no surprise. Maybe sometimes your application will crash, but if you count here, there are actually 100 symbols like this one. From this one till this one, there are 100. And this is actually 0xcc. So this is the printable character associated with the hexa value 0xcc. So every time you see this kind of characters on your screen, remember you are printing char arrays which are not initialized. And you see what's interesting? After the 100 characters of 0xcc is not stopping. It's still printing stuff. And after that, it's printing hello course 05. Yeah, but this was where? This was another string in memory, which we used earlier. So what's
it overrun the buffer?
Exactly. It's what we did 3 weeks ago or 2 weeks ago when I showed you that if you just continue using, if you have a pointer on that function stack and if you just use it, you can actually go through the entire stack. So why this function, the cout end line get name, it's printing the name and everything else on the stack, including this one. You see, it's on the main function stack. It's still there in memory because remember, all functions which process arrays of characters, they stop on what? On \0. But we don't have a \0, and that's why it's not stopping. So you see, it's just printing until maybe we are lucky and it will crash. So we will see the pop-up and we will know instantly that we have an issue with our program, or we have a bad day and by coincidence it's founding a \0, and you see it has found the \0 from after 05 here, from the hello course 05 message, and that's why it has stopped here. But otherwise it could just continue printing whatever. Okay, so this is an effect. Every time you see this symbol on the screen, this is the cause. You forgot to initialize the array of characters, or maybe you you missed the backslash 0, and the function doesn't know where to stop, the printing function. Okay?
Teacher?
Yeah.
So without the end line, it would also
End line
print.
is just the enter. End line is just to print it on the next line.
Yes, yes.
Okay. So what was the question?
Without it, it would just print the length of the message is 15, right?
So I have this message. The length of the message is 15. Okay. And without which end line?
Yeah, like if after hello course 05 wouldn't be an end line, then it would continue and show the length of the message from what I understand.
Exactly, because the length of the message will be also on this function stack. But here we have a backslash 0, which is set when we have defined a string. So this has been printing the name of the student, 100 characters. And after that, in memory, after Alice, remember, this is a stack and it's written in reverse. We talked about this. Okay. And by coincidence, after Alice's name, we got the course 05, hello course 05, and the backslash 0 from here. Yeah. And if we wouldn't have the backslash 0 here, it will just continue printing maybe this message. Yeah. Okay.
Okay.
So always watch out for this kind of stuff. When you print a char array and you see this, or the message is not stopping, always go back to the source code and ask this, hey, where do I have initialized that array? We didn't. Okay. So the name is not initialized. All the 100 characters are 0xcc. And that's why it's not stopping. We are missing the backslash 0, and we are missing, let's say, information that would make sense, like Alice instead of 0xcc. Okay, so in this way, we provide read access. But remember, with this...
But the solution to fix this would be to write a string instead of a char array.
Where here?
Yes.
Yeah, so that will be always return a copy. Always return a copy of your array. Don't return the address of that array. So let me show you why this is dangerous. And after that, I will fix it like your colleague said. So I will just show you one way to fix this one. So why that is dangerous? Because you see, you say to me, I will give you only read access. So what will happen if I do this? Student Alice, okay, get name. So get name returns what? Returns a char pointer. I can write it here, char, and let's say this is Alice name equals. So I got your pointer, and now I can do anything with that. So let's name Alice. Alice name, index 0 equals A, or I can use a string copy, but it's the same. This is string copy manually. Okay, L. Okay, so 0, 1, 2, I. So Alice and the backslash 0. Don't forget about the backslash 0. So Alice, this will be Alice. Okay, 0, 1, 2, 3, 4. If I forget to set the backslash 0 here manually, so if I forgot to write this,
The same thing will happen as before,
exactly.
right?
Yeah, you will see Alice and all those strange characters. So let me show you this. Start, and this is a common error. You will do this a lot of times. So now you should know why you will see that. You see? Yeah, sorry. You don't see because I need to repeat this line here. Okay, so yeah, I will comment this one. So build, rebuild, debug, start without debugging. And here it is. At least now we see something. You see, Alice's name is Alice. We don't have the backslash 0. It's just continuing printing all the other 95 0xcc. And now it found other stuff in memory. Okay, it stopped after this heart and the dot, but these are residual data from the stack. Okay, so if you play with char arrays, don't forget to set the backslash 0. Obviously, here I would use a string copy because it's faster. This is /0, backslash is the other slash, right? Okay, so backslash 0, build, rebuild, and debug start without debugging. 1 second. Again, Windows Defender, it's not allowing me.
Quick question.
Yeah, please.
If we were to just run with Control F5, wouldn't it also build the current solution?
Yeah. So every time
Oh.
you run with Control F5 or start with debugging F5, it will always build the solution. But let's say for me, it's a habit. I can't escape it.
All right.
So yeah, I'm broken. I'm already broken. It's very difficult to convince me not to do the build. Okay, so I feel the pain of a lot of previous bugs if I don't do this. So yeah, this is the way to I don't know, to heal myself. Okay, so you see at this point, that's why I said earlier that if you return the pointer to a value, you are actually giving me the keys to the entire castle. Okay, so don't return pointers because I can actually change it. You see, now I'm changing your name, and normally if get should return only the value, it is just a read interface. I should not be able to change names, right? But I can because you give me the pointer, and that's the power of pointers. It's the address, and once I get the address, I can do whatever I want there. So how do I fix it? So your colleague's suggestion is right to return a value, the string of that. So how can I return only the string? Now we talked about strings. So I think I can do this string get name. I will leave also this method. Let's call this one get name value. Okay. I just want to keep both versions of the function in the source code. So you see now I will say, hey, I will give you the value as a string, because if I'm giving you the char asterisk, then it's dangerous. You will change my name. So how do I convert a char asterisk for a char array into a string? That's easy. There is a function which is actually the string class constructor, which can receive a char array, and it will convert that to a string. Okay, so in this way you return the string. Now, if you still want to return the char pointer, obviously you need to return a different address, not yours. Okay, so get name value as pointer. Okay, so we don't need to return this name. So I will say this, hey, I will make a copy of my name. So let's do the copy, char asterisk name copy. Let's call this one name copy equals, I will create this. You see, if I will create it here, I can do that. But what will happen with this array when the function terminates? So I will give you the address of the name copy, but this address will point to what? To the get name value as pointer stack. And when you will try to get this value, there is nothing here. Okay, we did this last week. Okay, so we covered that. Never return addresses of variables or arrays which are defined here on this function stack. You lose the function stack when the function terminates, and you will get an address of something which is not here anymore. So if you want to return a pointer of something, just create it somewhere where you know it will just stick with you until you decide to destroy it. And that means in heap. So char asterisk name copy equals new char. So I will make a copy. And what's the size? String length of this name. Okay, so I will create a copy. Remember, string length copies, counts until \0 without \0. So we need the +1. And watch out for this error. This is another common error. +1 here. So no one will say anything, but this name +1, this is pointers arithmetic. So instead of counting the letters from Alice, from A, when you say this name +1, you start from the second letter, from L. So here you are actually counting with one letter less and also without the \0. So this char array will be with 2 bytes less than what you need, which is worse. Okay, so watch out where you write the +1, because here we'll do pointers arithmetic. So we want to count how letters we see until \0, +1 because we know we need a byte for backslash 0. Okay, and after that I will say string copy. Okay, name copy is the destination, and the source is name. Sorry, the other error. Okay, if I do a build rebuild, it will say string copy is unsafe. So we can use the define pragma, okay, with the define CRT secure no warnings. Well, I will do that maybe in the next weeks. Now let's use the string copy underscore s. The difference is that here between the destination and the source, you need to pass the maximum number of characters, which in our case is this one. So this is the maximum number of characters. Okay, that's the difference between string copy and string copy underscore s. So the safe version of string copy will also ask you, hey, what's the maximum number of characters that I should copy? Because sometimes the name here could be bigger than the destination. So in this way, you copy only what the destination can accept. Okay, and now I will, yeah.
This is the equivalent of string and copy.
String and copy, like what? Do you have here a string and copy?
I know I use n, str and n.
String and copy. When you pass the size, right?
Yes.
Yeah, it's similar. Yeah, exactly. It's the same.
Thank you.
Okay, so actually string copy underscore s, it's similar with string and copy, which also was copying the given number of characters. Yeah, so it's the same.
Okay, thank you.
Okay, so this should be the way to return the name, because the name is actually a pointer. Okay, here we have a pointer to that array. Okay, so this is the public interface of the class. Okay, so encapsulation means make everything protected, seal that box, and now decide how others can use the box. So you see right now, anyone can use the student just to read the data from it. And now you may say, yeah, but sometimes we want to change the student. Maybe, I don't know, the student will take an exam, so I want to add a grade, or another year has passed, so I need to increase the age of all my students in order to keep them synchronized with reality. So the public interface should also provide ways for others to change the values. So what we have seen here, all the get methods are for reading, to provide read access. So let's provide write access. Okay, and again here you see I'm in the public area of my class, so which means these methods can be used from outside the class. So how these methods look like? They look like this. Again, I will say set instead of get. So this is it's not a keyword, but everybody will name these methods like this. It's like a informal rule. Everybody knows it, everybody's using it, but it's not something that the compiler will say something about it. So again, all these methods will start with the set word, the set prefix, and after that you use the name of the attribute. So I want to set the age. So what a set type method should return? So for get methods, it was obvious. All these get methods should return a value which corresponds to the value of that attribute for which you want to provide read access. Great. So set, what's the scope of set? To set the value. So generally set methods, they don't return because their role is to allow others to change the attribute. So generally you don't return from that. You just change the value. Again, this is a method which is defined inside the class, and which means by default gets the same bonus as all the get methods, which is the address of the object, which will call set age. And again, that pointer, it's called this. Okay, so what do we need to change the age? We need the new value, new age, new value, okay, or value. We need a value, because that's the idea. So you have a student with an age, and now you want to change it. So what this function needs, that value, because by default we'll also receive this pointer. So how would you write this stuff? this age equals value. Okay, now you understand here should be one important reason why they choose to pass you the pointer and not the value. So some of you will say, oh, so they are actually the entire universe is trying to fail us. So they were defining this as a pointer. So for sure they want to fail us because we hate pointers. Now let's skip the subjective part. So if you remember when we talked about transferring values to and out of functions, we tried to do the interchange without pointers, right? And it didn't work because you got only the values copies on that function stack. We were changing those values, but we were not actually changing the main function variables, VB1 and VB2, if you remember. So the solution was to make that function, which was called interchange, to be able to access the main function variables, the original VB1s and VB2s. And for that, we were using pointers. And I said to you, if you want to make a function which will have access, read and write to other variables which are placed in different locations in memory, not on its stack, you need the address of those variables. So if you want to write a function which will change something, you need the address of that thing. And now I think you should understand why they are giving us the address of the object and not the value of the object. Because if this would not be a pointer, all the changes that we will try to do here will have zero value outside of this function. And that's why this is the pointer. This is the reason why this is a pointer. Because now set age has access to the student, and now we can actually change the student age from set age, because this is the pointer to that student. And obviously the student is not here, is not inside set age. The student is here in main. You see it, it's on the main function stack. All the students are here. And that function will receive the address of Alice and John. And because it receives the address, that's why set methods and other methods work. They can actually change the object. Okay, so that's why we got the pointer. We get the pointer because with the pointer, we can do the change. Okay. Now, if you define the set methods like this, please not waste your time. Okay, I think you can do better things with your life. But if you define set age like this, and I presume you also have get age, which everybody knows how to define it. Okay, it's quite easy. But if you define set age like this, I don't know, let's get 10 minutes out of for our real life. I don't know, read a book or something and not wasting them on this thing which has zero value, because it's better to make age public. So if you provide age private, if you define get age and you implement set age like this, trust me, it's better to actually make age public, because in the end it's the same. Let me prove to you. So we are talking about encapsulation because we want to avoid this to happen, to allow others to set a negative age. So if you implemented age like that, who will stop me to do this? Student Alice, set age minus 21. Who will stop me to do this? No one. Yeah, it's like, okay, I could not do that directly, so now I can use a function. But in the end, minus 21 will be your object age. And this is what we wanted to prevent, because now we are responsible. And that's why I'm saying it's better for you to make the age attribute public, because in that way you may say, hey, sorry, I forgot. But if you define set age like this, you have no excuses. So what do we need to do in the set methods? Because without that, like I said, it's better to make the attributes public, because you gain nothing here. What do we need to do? Validate the input. Always validate the input. Remember, we don't want to allow them to actually insert negative values. So we need to validate the input. If we don't validate the input, it's everything, all this stuff is for nothing. So let's validate it. So what's our rule? let's say we accept values which are positive, but let's think for a student, let's say we accept values which are greater than, I don't know, which is the youngest student, maybe 10 years or 14 or 12 if it's a genius, whatever. So let's go for 10 years. So if value is greater or equal than 10, okay, I will open brackets. I will always open brackets, even if I do only one thing, okay? Because in this way, if I want to add other stuff later, I already have the brackets. So in that case, age will take a value. This age equals value. Great. So I can change it if you pass me a correct value. Again, here I will say, yeah, but okay, minimum 10, but also should not exceed what? Let's say 110 or 100, let's say, or 90, whatever. Again, I don't know which is the world record regarding the oldest or the youngest student ever. Okay, so if you pass me a value between 10 and 100, including the limits, I'm okay with that. Now, what do we do on else? What would you normally do? What's your first idea to do on else?
Not to change the initial value.
Or ask for another value, I don't know.
Okay, great ideas. So the first idea is not to change. It's like not doing nothing, right? So it's like, yeah, the value is wrong. I will not change anything, okay? And I will tell no one, okay? And the second one is to, you said to what? So not doing anything. And the second idea was to, can you repeat that?
To ask for another value.
Okay, to ask for another value. So in order to ask for another value, I need to open here a console and I will say, hey, the value is wrong. Please insert me another value. Now, generally, we will try to avoid using the console inside class functions because maybe I will want to use this student class for a machine or a device which does not have a console. So always try to separate the interface from your classes, okay? And you will learn about this stuff. Here we are already talking about architecture patterns like MVC, model view controller. And you see the model here is the student. So the only purpose of the model is to store data, to manage data. So always try not to make the models do more than they should normally do, like printing or interacting with the console. So we don't do that. But the idea, it's okay. But generally, let's try to learn in a way that it will be useful for you in the future. So try to separate things. Okay, so don't try to ask for, don't interact with the console inside your models, inside your classes. Okay, so the ideas are okay, but let's say the first one, so you see for else, why I personally don't like this approach, not to do nothing. Because you see here, if someone will try to set student Alice age minus 21, from this perspective, do they have any idea that nothing has happened? So do they have a warning or something to tell this programmer, hey, even if you pass us a negative value, we will not change it? So you see, the programmer here will believe that everything is okay, that no one said nothing. Okay, so they would expect that Alice's age should be minus 21 now. So that's why it's not okay to say nothing. Okay, so this is one reason why I will choose not to do nothing. The second one, what your colleague said with the console, we try to separate things because it will be quite a surprise for those programmers, because they pass you minus 21 and after that their program, it's stopping and they see a prompt. The age is wrong, give me an age. And everybody will be like, whoa, from where that message came out. Okay, they will try to search through code. So who is asking for the new age? And actually it's hidden here. So that's why we try to separate things. So let's forget everything that we know. Now, if someone is calling set age with -21, do you think it's okay? Do you think it's okay that they even try to do that? Do you think it's a cool thing to ask to set the age to -21? No, it's
No.
like a bad joke, right? It's like, hey, why are you doing that? And in programming, please remember this rule. Calling a function with wrong values, it's stupid by definition. Why? Because if you call a function with wrong values, what do you expect to happen? You should never call a function with bad values because nothing good will happen. The values are bad, right? So this should not exist. So let's suppose they do this. Now, what do you think they do this? I don't know. Let's ignore the fact that maybe this is a bad joke. Maybe this value, they get it from the interface. Okay, so another developer will implement the console module, and now the secretary will see, hey, give me Alice's age, and they take the value from the user. And obviously they don't validate, because when they get -21 from the secretary, that module should say to the secretary, hey, sorry, you passed me a wrong value. Can you give me a good one? You see, you should never allow the users to give you bad values. Okay, don't make decisions for them. If you get a bad value, then you stop the user and you say, hey, you have an error. Give me a good value for age. Okay, never allow them to do that. Always validate. So obviously they didn't validate. So how can we make this a statement so the developer which is receiving this age from another input is not validating and is passing us the wrong value? What's the only thing that programmers see when they test the application? Is when the application crashes. So in our set methods, and this is the way we will program to the entire semester, and this is the way you will do it. If you get a wrong value, you crash the application. Because in that way, when they will test it, they will see it. Because this is not normal to get here a minus, okay, a negative value. So how do we crash the application? It's quite simple. In order to create that pop-up, you have the throw method. And here you can write everything you like a number, like a message. So let's say wrong value for age. So what will happen when they will try to call set age with -21? Let's see, build, rebuild. Okay, debug, start without debugging. Again, here it is. Okay, so they get this, and it's obvious. Let me show you the entire screen. You see, they realize that they have an issue. Now I will show you, because we will do the try catch in 3 or 4 weeks. I will show you how to catch those messages and actually to print them. Okay, so that software developer will be able to catch that message, and obviously then that developer will realize that it didn't validate, and maybe then, but they will do that, not us. They will ask the user to give us a wrong value. So making the application crash is quite the thing that we will do, is recommended to do when you get a wrong value. Okay, now this is one way of doing, and generally here it's not you'll understand this. I will explain you this in 3 weeks, why it's not okay to just throw messages. We should throw objects. So until then, just allow me to always throw this. So I will throw an exception, and this is another object from C++, which actually represents an exception, a runtime exception. So throw exception, and I will say wrong value for age. Okay, so remember this. We make this rule for our course. Every time you write a function and you validate the input, and the input is not what you expected, is not what you can use as a function, crash the application, throw an exception. Okay, so exceptions have been introduced in C++. They don't exist in C. In C, you can't throw exceptions. There are no exceptions in C. In C, here, you should return a code. For example, the set age should return an int, and if you return -1, it means the value was wrong. So this is the way in C. Generally, they return codes, error codes. But in C++ and all object-oriented languages, we have exceptions.
Teacher?
Yeah.
But why don't we see the message wrong value for age?
Why we don't see it? Because we don't catch it here, and the system by default will not show you the message of a generic exception. But I will show you how to catch this one and see the message. Okay. So this is a generic exception. Okay, and the system will show those messages only for particular ones. So here we are working with a generic one, but we will fix this one. Okay, we will see these messages. Okay, so this is the way we will write set methods. Always validate. Okay, so you see set age. Now, for the boolean, for has scholarship, how do we write this? Void has scholarship. Scholarship. Okay. Again, here, some of you will say, let's receive a boolean, has or not has. Okay, let's say value. Okay. And here you will say this has scholarship equals value. Now, for a boolean, we can't actually validate something because you see it's either true or false. So they both are valid rules. Now, maybe you came up here with a strange rule saying that if you already have a scholarship, you can't lose it or whatever. So it depends. Okay. So, and yeah, let's call this one set scholarship. Now, regarding Boolean values, because they have either true or false, here, this is prone to mistakes. I can, by mistake, call set scholarship with false when I actually want to call it with true. So for Booleans, it's much more clean for others to actually do this. Void gains scholarship. You see, and I will not ask you because the scholarship, because the method now is very specific. I will not ask you that, do you want to pass me true here? It's like, you see, you ask for true and here you validate. And if I, by mistake, I give you false, you throw an exception. Now, let's be smarter than that. If I call gain scholarship, it means the student has a scholarship, right? So has scholarship, true. So when you do that, don't ask for true because they will pass you false, okay? Or, and if you want to remove the scholarship, lose scholarship or loses scholarship, loses scholarship, gains the scholar, loses the scholarship. Okay, and now here I will say this scholarship equals false. So for Boolean, try to guide the other developers. Okay, so you can provide, no one says you should provide only one set method or only one get method. No, the public interface can contain any number of methods you think will be useful for others. Okay, so in this case for Boolean variables, I will always prefer this one because you see they're less prone to errors. Here, when they will call this, they will understand that now the student has a scholarship, and then when they will call this, it will be false. So never ask for the obvious. This is what I'm saying. Don't ask for a value here, and here you validate that the value will always be false. Okay, so if that will happen, don't ask for the value if only one value is valid. Okay, so don't ask for the obvious. Okay, so this will be alternatives for Booleans. Now, for name. So how do we match the name? So void set name. Again, here I will pass with a constant because I make a promise. I will not change it. Set will not change this the value here. Remember the name, it's a static array. So name, it's I already have 100 characters. So the only thing that I will validate here will be the length, because I can't copy more than 100 characters. So if value if string length of value greater than 99, because I need an extra for \0, okay, so I can accept only 99 printable characters. So if this is the case, again, throw will interrupt the function, so it doesn't matter. If that will execute, the function is terminated. So throw exception, and I will say here value too long, okay, and if else, and again here, if this will execute, the function is terminated, it's finished. So I don't need an else here, because yeah, I can write else, but again, let's reduce the number of curly braces.
Question, throw, in this case, throw just works like a return, right?
Yeah, but a return with a pop-up.
Yeah.
Exactly. So it's a return that they can't ignore. Okay, so that's why I'm saying it will terminate the function. And now I will say string copy this name and value. And again, I need to use the string copy underscore s, which here I need to pass. Here the maximum number of characters is 99, right? Because I already know that my size is 100. So here I will write 99. Okay, so this will be the set name, the set method. Okay, so let's see them. So this will crash. I will comment it because it will always crash. So let's see. Student Alice set name. And let's say, yeah, let's change John because Alice already got her name. So let's say John, student John, set age 21, and student John gains scholarship, which means has a scholarship. Okay, and I don't need to pass the true or false. And now if I want to print John name, just to check if this is okay. Name is, and here I'll say student John, get name, and do a build rebuild. Okay, debug start without debugging. Now everything should be okay. Okay, so student name is John, and I can check all the other attributes. Now, before ending, I have only one question, because let's end this day in a way that we can, let's say, we can actually be productive. So you see, here we are creating a lot of students with those defaults 0xCCC, which is not okay, because you will say, so every time I will define a class, I need to define the getter and the set methods. Okay, and after that, I need to create an object like this one. And after that, I need to set the values, because by default, I get 0xCCC and I will see a lot of strange symbols on the screen. And the answer is yes. But what will happen if you don't provide the set attribute? Maybe that value is sensitive. So the question is, can we actually create objects with values? Because I don't want to create objects with default 0xCCC. That's looks very unproductive. It's kind of useless. Those objects are useless.
But I have a question.
Yeah.
Can't we use files to do that? Like
files for what? For reading the data from
yes.
Yeah, we will do that. Yeah. So instead of typing each day and introducing data every time we run the application, yeah, we will load them from files. And yeah, that will solve the set, because then we will call the set methods. But let's suppose we don't have files. How do we fix this? How can we create objects with some values that we want to set when they are created? That will be cool. Because you see, at this moment, I'm kind of forced to provide set methods for all the attributes, right? Because it makes sense. All our students will be with 0xCC. So in order for anyone to initialize them, all the attributes with proper values, we need to provide set methods for all. But I just said to you that maybe sometimes we don't want to provide a set method. Maybe that value should not be changeable. So In order
Can't we
to
do the same thing that we did with structs that we can do with struct?
like what? Like initializing them when you define them here?
Yeah.
Yeah, exactly. So obviously we need something that will allow us to initialize objects when we create them. And this is a kind of a special function because it's special because it's not following the normal pattern of defining a function, which means this function, there could be many, will always have the same name as the class. So I will define a function which is called student. And remember, this is always its name. The function does not have a return type. So you are not allowed to write anything here, including void, because this function scope is to actually allow us to create an object and to initialize it. So this function will allow us to create objects and initialize them. So for that, we need to ask for values. So I want to be able to create a student with a name. So I need a name, const char name, with age, and with a scholarship. Bool has, the names are not, here you can have any values. I'm just reusing these values here because in this way it will be easier to read, but this is not mandatory. So right now, again, this function, because it's defined inside the class, will receive the this pointer. But at this moment, this represents the address of the object which is created. Okay, so we can initialize them. Now, we already have some functions which are already validating. You see them? We already have set age. We already have set scholarship. We already have set name. So if you try to validate again the values here, you will do what? Copy paste from here, right? Copy paste this part, copy paste this part. Don't do that. And that's why every time you define a class, you define the set methods and the get methods, because if you have them, we will just call them. And we have already the validation there. So set age of age, set scholarship of has scholarship, and this set name of name. And you see, we don't need to do copy paste because we already have the perfect set methods, and now we will reuse them, because if someone will pass us a wrong age here, set age will throw an exception which will interrupt also this function. Now this function is called class constructor because this is the purpose, to construct an object and in the same time to initialize it. So how do we use it? Here, instead of creating empty objects like student, empty in terms of 0xCCC, now I can say, hey, this is actually Alice, age 20, has scholarship, true. And here I will say, hey, this was actually John, okay. And now you will say, I don't know, 21, maybe John does not have a scholarship, false. Okay, and in this way, we will actually create objects with some values. So we don't need to go through the setters, okay? And this is the way we will work, okay? We will define for all our classes setters and getters, and we will define constructors. Here we can have multiple functions, and this is what we will do also next week and at the laboratory. We can have multiple constructors with different combinations. Now, the last question is, so based on this approach, we need to have all the set methods. And I said to you, this is a good thing, because in that way you validate the values here, you break this process apart into small pieces. Okay, now, what can I do in order to implement the set method, but let's say I want to keep a set name only for me. So what do I need to do to this class in order to implement set name, but to allow set name function to be used only by me and not by others? Because in that way, I will block their opportunity to change the name. let's say I don't want to allow anyone to change the name. So what do I need to do here in this class in order to prevent that without deleting set name? Because I need it here in the constructor.
We set it to private.
Yeah, you make it private.
Exactly. You see, and in this way, you can still define methods just for you. So set name now it is usable by us. But if I write here private, which means from this point on, everything is private until the next label or the end of the class, looks what's happening in main. They can't change the name anymore. They can set the name when they build the object, but they can't change it. And in this way, we play with private and public. Okay, because now we don't allow them to change the name, but we can still use the method here. Okay, so a lot of new stuff for this course. Like I said, the pace will increase.